5, 4, 3, 2, 1.
Science holds the key to our survival as a planet.
But science is cumulative.
Modern science
is the knowledge.
Hello and welcome to our podcast. My name is Ali and I'll be your host for today's show. I have the pleasure of welcoming a special guest, Elias, who is an astronomy and cosmology enthusiast and also a computer programmer. He'll be talking about the Coriolis effect and Saturn storms. So without further ado, let's let him introduce the topic.
I decided to make an episode today as a request for Ali, and it's a great pleasure to talk about astronomy and cosmology today. So we know our solar system has millions of stars and a couple of planets, thousands of planets. The most important are in our solar system now. We all know them, which are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and in my personal opinion, Pluto is still a planet, but they call it a dwarf planet. That's not our topic for today. We're going to talk about Jupiter's thunderstorms. So on Earth, we know that storms rotate within the Earth's atmosphere. So as the Earth rotates, the storms on Earth rotate in the same direction.
And so he talked about the rotational direction of storms on Earth, but then talked about Saturn.
Scientists have discovered that the storms on Jupiter goes from left to right. It's a reverse thing as on Earth. And it's a very interesting topic that they found out the answer now. On Earth, we know that there's something called the Coriolis effect. So I've added a link in the description box. Please check it out. It's about the Coriolis effect, and it's one of the that causes our storms to rotate in the same direction as the rotation of the planet. But on Jupiter, they rotate in the opposite direction. Jupiter, we all know, is a gaseous planet, and it is mainly made of hydrogen and helium. Within 90% of the planet's radius, the high pressure from the atmosphere above makes the mixture metallic and able to conduct electricity. The thunder conducts electricity, which causes huge physical damage on Earth.
He then talked about the magnitude of storms on Saturn.
There have been huge storms. Believe me, they are much more powerful than those we see on Earth. It's around 15,000 times stronger, and it's been for 500 years now, since it was last spotted something in the 1500s.
And finally, he talked about Saturn's notorious red spot,
known as the Great Red Spot, which has been spotted by a scientist, as I told previously, in the 1500s, which is 3 times the size of Earth, and it has been more than 500 years. And I've read a lot of texts that say it's much more powerful than Earth's. In addition to its size and durability, the red spot has other special features, such as a characteristic color. Additional processes seem to be involved here that we don't yet comprehend.
And all this goes to show you that even with the colossal amount of scientific data that we've accumulated throughout the years, there's still a shitload of stuff to be discovered. And we are making important scientific discoveries every day. And that's the main goal of our podcast, is to make that information readily available to you, the listener. And moving on towards other important news that popped up this week, there have been major advancements towards affordable PEC production of hydrogen. And I'm going to explain this in detail. First of all, PEC stands for photoelectrochemical. And the photoelectrochemical process of producing hydrogen is by splitting water molecules, H2O, into hydrogen gas and oxygen, using solar energy. And this whole process requires special semiconductors, PEC materials, and catalysts. And the most important part of these materials are catalysts. We usually use precious metals as catalysts, such as platinum, ruthenium, and iridium. But the problem is that a large-scale commercial effort would not be cost-effective. So that's why cheaper molecular catalysts were proposed. But the problem with these catalysts are that they are unstable and they have a very short lifespan relative to precious metals. And to explain how these catalysts work, they are mixed in a liquid solution surrounding the semiconductor. So scientists have tried to remove these catalysts and attach them directly to the semiconductors to achieve better results and efficiency. And they were actually able to do that by putting a layer of titanium dioxide, TiO2, between the semiconductor and the catalyst. And surprisingly, they were as active as the precious metals, but they were unstable. So each evening the whole system was shut down to give time for the catalyst to regenerate. Moving on, in a few years people might be walking around with glass in their mouth. You heard it correctly, glass. But not ordinary glass, this is bioactive glass, which will replace conventional tooth fillings. And this is very important because it prolongs the life of tooth fillings exponentially. Each year, over 122 million tooth restorations are done, and this is in the US alone. In addition, the average person chews more than 600,000 times per year. And this is where this fascinating new piece of technology comes out. Because the bacteria in the mouth that are responsible for causing cavities don't seem to like this type of glass. And so it lasts much longer than conventional tooth fillings. And if these lab results are confirmed by clinical research, it should be very easy to incorporate bioactive glass into existing formulas. So we should probably be able to see these types of fillings popping up in clinics around the world. Next, we know that carbon nanotubes are extremely powerful. We use it to reinforce all kinds of materials. It is 30 times stronger than Kevlar, and Kevlar is used in the production of bulletproof armor. These nanotubes are also lightweight and strong, which is perfect for building airplanes, spaceships, and sports equipment. But a group of scientists have recently discovered that boron nitride nanotubes could be even more powerful than carbon nanotubes, because they are much more stable at high temperature and can absorb radiation more efficiently. And this is very important for building spacesuits for astronauts. Boron nitride nanotubes are also piezoelectric, which means they generate electricity when you stretch the material. So say you're walking around in a boron nitride vest, well, each time you flex your muscles or move your arm, you're generating electricity. But the main drawback is cost. It costs $1,000 per gram compared to $10 to $20 for carbon nanotubes. But when carbon nanotubes were first produced, the cost was pretty similar. So within the next couple years, we should see a large drop in price and people beginning to adopt these new kinds of materials. Thanks for listening, and I hope you enjoyed today's show. Our next episode will be a New Year's special, so stay tuned for updates. Also, don't forget to subscribe and share.